Okay, Algebra 2 class, here's your promised lesson on Lesson 35, video on Lesson 35 that we didn't get to in class. Believe it or not, even after an hour and 45-minute class, we still didn't get to this. So this is good. I'd rather take my time to explain it. This is Lesson 35, Angles and Polygons, which we did in class. Remember, we're going to figure out how many triangles there are in a polygon and then take the number of triangles times 180. And then we're going to do inscribed quadrilaterals and fractional exponents. But before we do that, we're going to talk about the sum of the measures of the exterior angles of any polygon is 360. So depending on the number of sides a polygon has, tells you what the degree of the interior angles are. But the exterior angle of any polygon, no matter how many sides, is always going to be 360 degrees. So let's try this problem. I think we tried this in class, but we didn't. I was rushing and didn't really explain it well. Okay, so here we have a 1, 2, 3, 4, 5, 6-sided figure, and we're going to figure out what x and y are. We're going to use this definition, the sum of the measures of the exterior angles of any polygon is 360. So what we're going to do is just take and add up all the exterior angles and set it equal to 360. So we would have, if we start here with 80, we'd have 80 plus exterior angle here is 40 plus 30. Oops, that's a 50. Can't read my own writing. 50, 65. Then we have x, and then we have x plus 55. And that all equals 360. So we'll add up the number parts of this, and when we add it all up, we're going to get 290. So we have 2x plus, if we add up 80, 40, 50, 65, 55, we're going to get 290. And that equals 360 degrees. And then subtract 290 from both sides, we get 2x equals 70. And divide both sides by 2, we get x equals 35. And then we can figure out y. You put this in for x, so 35 plus 55 is 90. And these two angles are on the same line. That means they're a linear pair, so they have to add up to 90. So we know that y would also equal 90 degrees. That's all you do for these. Now if we were finding interior angles, I'm deviating a little bit. To find the sum of the interior angles, you divide it into triangles from one point. So we would have one triangle, and then we would have, let's see if I can draw another triangle. That's 2 triangles, 3 triangles. So I think I hit all the sides for those. So remember, I don't know if you remember this, but it's the number of sides minus 2 would tell you how many triangles there are. So there's 6 sides. You subtract 2, that tells you that there's 4 triangles, and then you take that times 180, and that tells you the degrees of the interior angles of the polygon. Just a little review. Okay, let's go down here to the next thing we learned. If a quadrilateral is inscribed in a circle, then the sum of the measures of any pair of opposite angles is 180. Yes, I did cursive. It's hard to read. Okay, so what that's saying is the sum of the opposite angles would equal 180 degrees. Now, if you remember from the past, we did if we had an inscribed angle. So do you see how this is an inscribed angle? This one and this one. See how this forms an inscribed angle right here? Do you remember that the inscribed angle is half of the sum of the intersected arcs? So we would know that z, this is the intercepted arc right here. So we would know that z plus 50 equals, it would be 160, because it would be double that. Or you would take half of this time and then 80 over here, so you'd multiply by 2 and get 160. Do you remember that? If it's a central angle, it's the same as the intercepted arc. So we're going to get z equals, if we subtract 50 from both sides, 110 degrees. So z is 110. See, it's an intercepted arc. This is going to be twice the angle. So that's why I did 2 times 180 is 160. So we have this is 160. Both of these together, so z is 110. Now let's try to find these. We know the opposite measure of opposite angles equals 180. So I'm sure there's more ways to go than one. But one way to do this problem is to do two equations. So we know that y plus 75 equals 180. That's because we know opposite angles of an inscribed quadrilateral is 180. And we know that x plus 80 equals 180. So we can figure these both out. So we would say y equals, I guess this isn't as hard as I thought, y equals 105 and x equals 100. I was thinking we'd have to solve a system of equations, but there's one variable, one equation. We can solve it. So these, you just set up opposite angles, add up to 180. And that's all there is to that problem. Okay, the fractional exponents, that's the more complicated part of this lesson. So hold on till I go get that lesson. There it is. Okay, fractional exponents. These are crazy. What a fractional exponent is another way to write a radical. So we can take the square root of 2 and we can write it as a fractional exponent. Just keep in mind the index is the little number that sits right here. Just pretend like there's a seat there. There's an index. If it's square root, we don't write the 2. But there is a 2 there. It's the square root. So how you write it as a fractional exponent is the number on the seat goes on the bottom. Your bottom goes on the seat, so that number goes on the bottom of the fraction. So 2 is the same as 1/2. Same thing here. You have the cube root of 3. The 3 is on the seat, its bottom's on the seat, so it goes on the bottom of the fraction. For right now, these are all going to just have a 1. Here's another one. We have 4 on the seat. It's a 4th root of 2, so you make your fraction. It goes in the denominator on the bottom. When you have fractional exponents, you treat them just like regular exponents. When you multiply, you add your exponents. 5/3, 8/3, 13/3. And here, if it's a power to power, you multiply your exponents. So let's give a couple of these a try. Okay, first one, 4 to the negative 1/2 power. You're going to see why we do fractional exponents, why we go back and forth. So this is negative, so we're going to move it to the bottom. You can't have a number with a negative exponent. So that'd be 4 to the 1/2. This time we're going to go backwards. We're going fractional to square root. So it's going to be 1 over the square root, because the 2 is the index. We go here, but we don't write that, of 4. The square root of 4 is just 2, so that simplifies to 1/2. Let's try another one. Okay, we have the negative sign. It just stays out there. This whole thing would go on the bottom, so I'm going to put a negative 1 on the top. You can't just have nothing on the top. And on the bottom, I'm going to write the cube root. I probably skipped a step that we might have needed, of 27. Before this, we would have wrote 1 over 27 to the 1/3 power, because we're moving it to the denominator. And then, if you remember what a cube root is, you say what times itself 3 times gives you 27, and that would be 3 times 3 times 3. So the final answer would be negative 1/3. Okay, here's a little bit trickier one. This one has a number other than 1 in the numerator. So what you do with that is the bottom one goes on the seat. Okay, goes on seat. So I'm going to make my radical. The 2 goes on the seat. The 16 goes under the radical, and the whole thing is to the third power. So this top number tells you what power to raise it to. So the square root of 16 is 4. 4 cubed would be 4 times 4 times 4, which would be 4 times 4 is 16 times 4 is 64. So it would be 64. Okay, let's try one more of these. Hey, your book doesn't give an answer to that one. Okay, and the last one. So you have the -1 stays on the top because it's negative. The 8 goes to the bottom and the exponent becomes positive. This is one of those double kind. So you get -1. The 3 is on the bottom, so it goes on the seat. You put the 8 under the radical and then square, because the 2 is on the top, square the whole thing. So you get -1. The cube root of 8, what times what times what itself, 3 times will give you 8, and that would be 2. And then you still have it squared. So you get -1 to the 4th power over 4. So it would be -1/4. Let me give you guys one of these to try from your practice problem, and then I'll let you go. Okay, try this one. This is practice problem E. So you have -125 to the -2/3 power. So pause the video, give this a try, and then turn it back on. Okay, let's see if you got the correct answer. So we would have -1 over 125 to the +2/3 power. -1 would be the cube root of 125 squared equals -1. 5 times 5 times 5 gives you 125, and then we would square that. So we get -1 over 25. These are slightly fun, I think. I don't think you'll mind these too much. Okay, that's it for the lesson, for lesson number 35. If I can stop the video, that is.